Okay, so yesterday I delivered the powers lesson live, but I'm going to do it again in video form for those of you who couldn't make the lesson. Here we go. What is a power? A power is this entire expression, 2 to the 5. The 2 is called the base and the 5 is called the exponent. You may want to stop the video and try some of these activities on this page. Okay, so the first power rule that we're going to talk about is multiplying powers with the same base. And the same base thing is important. So for instance, this is a 2 and this is a 2, same base. So if we did this the long way in expanded form, 2 to the 3 is 2 times 2 times 2. 2 to the 2 is 2 times 2. So this would be expanded form of this question. What we realize then is we actually have 2 to the 5. 1, 2, 3, 4, 5. So when we multiply powers with the same base, we'll need to add the exponents. This is similar, obviously the same with variables as well. So a to the 3 times a to the 2 is a to the 5. So we're just going to add the exponents. Keep the base, add the exponents. So a couple examples. Keep the base, add the exponents. 2 plus 10, so 11 to the 12. One more. Keep the base, add the exponents. 13 to the 10. All right. The next rule we're going to look at is dividing powers that have the same base. So 2 to the 5 divided by 2 to the 3. If we do this expanded form, because maybe we don't know this rule yet, what we see is 2 times 2 times 2 times 2 times 2. 5 of them on the top, divided by 1, 2, 3 of them on the bottom. So what ends up happening is 2 divided by 2 is 1, 2 divided by 2 is 1, 2 divided by 2 is 1, and what I'm left with is 2 times 2, or 2 squared. So when we divide powers that have the same base, we will subtract the exponents. So for this rule, we're going to keep the base and subtract the exponents. 12 to the 3. Keep the base and subtract the exponents. 15 to the 6. Good luck. The third rule we're going to look at is raising a power to a power. So this 2 squared is to the power of 3. It means I have 3 of these. 2 squared, 2 squared, 2 squared. In expanded form, that's 2 times 2, 2 times 2, 2 times 2. And you can see then I end up having 1, 2, 3, 4, 5, 6 2's, 2 to the 6. So and if we look back to our original expression, it's 2 and a 3. So we ended up multiplying those exponents. So the rule then is when you raise a power to a power, we need to multiply the exponents. Okay, so this next rule is the zero exponent rule. So it means that if anything has a zero exponent, the answer is 1. Why is that the case? Let's review a question that we've done before. Here's dividing powers. They have the same base, right? And if I write it in expanded form, 5 to the 3 is 5, 5, 5, and 5 to the 3 is 5, 5, 5 again. And again, if I were to use my division, 5 divided by 5 is 1, 5 divided by 5 is 1, 5 divided by 5 is 1. So 1 times 1 times 1 is 1. So 5 to the 3 divided by 5 to the 3 is equal to 1. But a moment ago we talked about what happens when we divide powers with the same base. So when we divide powers with the same base, we're supposed to subtract the exponents. If we subtract the exponents, 3 minus 3 is 0. So then 5 to the 0, so this answer is also 5 to the 0. So if it's equal to 5 to the 0 and it's equal to 1, then those two things must be equal. So 5 to the 0 equals 1. Or anything to the power of 0 is 1. Negative 3 to the power of 0 equals 1. 365 to the power of 0 equals 1. A to the 6, B to the 7 to the 0 equals 1. Anything to the power of 0 is 1. Okay, so the first few rules were probably reviewed from grade 9, but this one was not explicitly in the grade 9 course, so you may or may not have covered it. If we're talking about negative exponents, what happens when there's a negative in the numerator, or in the exponent? So let's look at a possibility here. If we have 5 to the 3 divided by 5 to the 5, in expanded form, this is what it looks like. Again, if we do the division thing, 5 divided by 5 is 1, 5 divided by 5 is 1, 5 divided by 5 is 1. So on the top I have 1, and on the bottom I just have the 5 times 5. So 1 over 5 times 5 equals 1 over 5 squared. If if I look at the next one, following the rules that we learned for division of powers, we end up subtracting the exponents. So 5 to the 3 minus 5, and then that equals 5 to the negative 2. So if we did the same question, 5 to the 3 here as here, then these two answers must be equivalent. So 5 to the negative 2, looking here, is equal to 1 over 5 squared. Or, in general, a to the negative n, a to any negative exponent is equal to 1 over a to that positive exponent. It's like we're flipping. You may want to stop the video and try some of these exercises to review power rules. Alright, so I'm going to try this one, but I'm going to start by simplifying the bracket first, inside the bracket, because there's a lot that's going on in there, like the 6 and the 2, the u's and the v's. And I'm going to rewrite it so that they are grouped together. So it's negative 6 over negative 2, u to the negative 5 over u to the 4, and v squared over v to the cube. Alright, so I rewrote it, just showing you the obvious groupings between the numbers, the u's, and the v's. So now I'm going to evaluate the inside. So this is 3, u to the negative 5 minus 4, v to the 2 minus 3 squared on the outside. Continuing to finish the inside, v to the negative 1 with the 2 on the outside. And now we know that this 2 impacts the 3, the 9, and the 1. So I'm going to fix that in the next line. So 3 squared, u to the negative 18, remember we're multiplying, and v to the negative 2. Now oftentimes questions say show positive exponents. So I'm going to rewrite this. Well, first of all, 3 squared is 9. And u to the negative 18 is 1 over u to the 18. And v to the negative 2 is 1 over v squared. And if you really want to make it a little bit prettier, the 9 is on top because 9 times 1 times 1 is 9. And on the bottom I have u18 v squared. Here are a bunch of small problems that you can practice your power skills on. Good luck!